Hello, Keith Rucker at VintageMachinery.org. Guys, today I got a shop visitor, Tim Riley, come down from up in North Georgia, and he brought along a project. Imagine that. So tell me about this vise, what we got here.
It's a vise I bought at a tool sale for 25 bucks, and it appears somebody used a drill press or maybe a mill and went straight through into the screw in the middle of the vise. And I'd like to get it fixed up and usable for my shop that I'm putting together.
Looks doable. So yeah, someone had this vise mounted, looks like on a drill press. And I can see where it says quick start on here, which is kind of a job training program. So I imagine this was like in a tech school or something like that. And some brilliant individual had this up on a big drill press, was drilling along, came out the bottom of the part and just kept right on drilling right down through the screw and went about 2/3 of the way through the screw. I'll show you a close up here in just a second. But what we're going to need to do is take this all off, get the screw out, and we're going to have to make a new screw for it. There's just no way to salvage that. So that's going to be the game plan for the day. And Tim's wanting to learn how to do some machining, so we're going to take him over to the Monarch and probably let him try to do most of this work with me kind of looking over his shoulder. So that's the game plan today. You ready?
Yeah.
Let's do it. So here you go. You can kind of see the damage in there. So they had a really big drill bit. Wow. I just can't understand stuff like this, but you see it all the time. So anyway, let's see if we can figure out how to take this thing apart and get that out of there. So first thing we need to do is get this old broken screw out of here. And it looks like we got a shaft and there's a collar right here. There's another collar on the other side, and that kind of captures the shaft where it won't go back and forth. And it looks like there is a tapered pin coming down through there that's just got that pinned in place. So I'm going to take a punch, get right on the what looks like the small end. Yep, there it goes. Just going to take a longer punch. It's not punched completely out yet. There it goes. And there's the pin, and that actually I don't think is a tapered pin. I think it's a straight pin, but that's fine. And now I want to see, I'm not sure if this is, it may be screwed on there. It may be just up on it. So yeah, well, let's see what's going on here. I think the first thing I want to do next here, normally what you would do is you would just unscrew this to get this out, but with all this gobbled up down here, I'm going to see if I can get my Sawzall with a metal cutting bit and just cut this shaft out short, and then maybe we can unscrew the block off the end and at least get the jaw off. And then we'll work on getting this part down here loosened up. Let me just go grab that Sawzall. There we go. I'm going to cut this into another piece just so we can get it out of there. All right, now we can get it out. And I also want to go ahead and get that back jaw off. And the way we're going to do that is just unscrew this. We got a nice hole right here, so hopefully when we get down there and get it unscrewed, it'll just drop out and we can take that movable jaw out of the picture. All right, there it comes. Wow, that thing is not wanting to come out. I think what we're going to do is we're going to take it over there and we're going to hit it with a torch and just cut that piece out. I mean, I'm just trying to get that out of the way right now. We're going to make a whole new screw. We're going to have to make a new one of these, I'm sure. So let's just do that. All right, let's cut that piece out.
There you go.
It's got one side off. There it goes. Now, this thing should come out. So, yeah. Well, guys, I think we got it out. It's in a bunch of pieces, but that's all right. We're going to be remaking all this anyway. But you can see that little collar, it was actually threaded on there, which is fine. I don't know why it was not wanting to unscrew, but it was just absolutely not going to. But we got that out of there. I ended up just having to cut it again up there close because it wasn't wanting to come through, just where we had some burrs, I guess, where we used a torch in there, but it doesn't matter. It's out now. But you can kind of see what we got to make. We're going to have to make a whole new screw here. And we're going to have to make this little nut here to go up on here to screw in. And I think that's pretty much what we're going to have to do. So let me see your material you brought. He brought along a piece of metal here. Now, the original, it looks like, was all this, which is, I'm guessing, 1 inch. Let me get my calipers and see. Yeah, 7/8 actually. So we had 7/8, looks like a 8-pitch acme. We'll double check that before we start cutting threads. So originally it had a 7/8 inch shaft, and they had the 2 collars. Now when he measured it, he was measuring this collar here, which is 1 3/8 inches, and he got a piece of 1.5 inch metal. No big deal. You know, we probably could have just got a piece of 7/8 inch metal, not had to do any turning on it, but since we've got this, we're just going to actually turn this collar into the piece, and then we'll thread out there. So this will all be one piece instead of having a pinned on collar, which is actually probably better, but that's going to be the game plan. So let's get this over to the lathe, and we'll get this thing set up to start doing some turning. So I got this set up over here. We're going to turn it between centers. Well, we're going to put a center on this end rather, but unfortunately this is too big to go up through the headstock on the lathe, so I broke out the steady rest, which I haven't even cleaned up and painted yet, but fortunately it's in good shape. It's working. I got this in the 4-jaw chuck. I've already run an indicator on here. We got less than a thousandths of run out on either end, so we're good to go. And fire the lathe up. And we're going to start by just facing the end of this and getting a nice surface on there to start with. Touch off and just face that front. You want to try it? We'll just take a little bit of a light pass and just feed it in nice and slow. So you get all the way down to the middle. Nope, go the other way. There you go. Keep it running. Try to keep it moving slow. Want to get a nice surface on that. Keep on going. All right, so now we'll back off. pull it on out of the way, pull it on out. And now we're going to come in here with our center drill and put a center hole in the end. A little bit deeper than that. So the guys that watch my channel regularly will know this is a fairly new machine for me, this lathe. This is actually the first real job I've done on it. I've played around with it, but this is also the first time I've used the tailstock. And the tailstock down here I had restored, and one of the things that I have not done yet is getting it lined up properly with the spindle, and this is a great opportunity to do it. So what we did is we just came in here and I just made a pass down through here, just a light pass to clean some metal off. And what I'm looking at is the difference in the diameter from one end to the other. So down here we're at about an inch 412, we'll call it an inch 412 thousandths, let's just say 412 thousandths. And down on this end we're at an inch 459. So as you can see, we're turning a taper. It's bigger on the back side than it is on the front side. The reason is because the tailstock is actually out of alignment just a little bit, and I need to adjust for that. And it's made to do that, and I just haven't done this adjustment yet. So we're bigger on this end. So the tailstock is back, it needs to come forward, and I need to basically bring it in half of the difference between those two numbers. So we'll do some math, figure up how much we need to move it over. We'll adjust the tailstock over, take another pass, and make sure we're cutting a nice parallel cut. So let me do some math, and we'll be right back and show you moving that over. I made the measurement, we were 46 thousandths out. So subtract that in half, because we only want to take half of it out, because we're taking half off of one side and half off the other. So I need to move my tailstock toward me 23 thousandths just to verify the needle goes clockwise, it's coming toward me. So there's two set screws, one on either side, and that adjusts the tailstock from one side to the other. So I'm going to loosen this one up, and we'll come over here and we come around the back side. Should tighten this one up. Whoops, nope, I'm gonna have to go the other way. I'm gonna loosen this one up. Here we go. And I want to go 23 thou. 1, 2, 3, right there. So that should compensate for that taper now. What I'm going to do is we'll take another light pass down through there. We'll measure it again, and if need be, I'll make another fine adjustment. Just bringing up where we're at, we're pretty much really kind of ready to start the job now. I've got this outside diameter turned down to the diameter of that collar that we've got to turn, and I got a mark here. Basically, I need to turn this whole area from here down to 7/8 of an inch diameter. I will tell you, we went back, and after adjusting the tailstock the first time, I still had 8 thousandths that it was out, so I came in and made another slight adjustment. We moved it closer to me 4 more thousandths, made a pass down through here, and it's dead on. So I was getting the exact same measurement within a half a thou all the way down through here. So I'm real happy with that. We're turning nice and parallel, which is good. So I changed this tool cutter out. The other one was actually going to hit the live center, so I got one that's kind of angled up in here a little bit better. So we'll come in here, touch off, and let's see, 10, 20, 30. I'm going to start with a 40 thousandths cut and just kind of see what she does. I changed that insert out. This is cutting much better now, so we're going to continue on down and get her down to 7/8. So this is Tim's first time on a lathe, so I'm kind of teaching him how to do this, but on the graduations on the dial, we got a line for every thousandth of an inch that we move the cutter in. But remember, it's round, so you're cutting off on one side, that goes to the back side, so you're really, in essence, cutting off the front and the back. You're really cutting on one side, but you're removing metal on all sides of that piece of metal as it turns around. So every thousandth of an inch that you move it in, you're removing 2 thou. So each line is a thou, so that's going to be 10 thousandths here. It goes 40, that's 50 here, 60, that's just an increment. We were making a 40 thousandths cut a while ago, and it did that just fine. Let's do a 50 thou. So what I want to do is just move by 5 of those big lines. So we'll go 40, 50, 60, 70, 80, 90. So we're going to go all the way over to here. So, yep, keep on coming, real nice and slow. Keep on coming, right there, okay? All right, go ahead and engage the feed. And we're cutting away. Nice and slow and easy. Okay, that's good. Roll it back out to the end. $210, $210, okay. Guys, I just told you wrong because I've never had a lathe that was like this. Every lathe I've ever had, it reads, and when you dial it in, it's telling you how far it moves the compound in. This lathe here, it's actually compensating for that extra. So normally, even though it's reading in thousandths of an inch, you're really cutting 2 thou. On this one, it's actually a direct reading, which I like because you can do a little bit more accurate turning down to that thousandths mark. I was noticing that the lines were really close together. And then too, I was noticing that I said I was making a 50 thousandths cut, and I'm like, that don't look like a 50 thousandths cut. So I was really only making a 25 thousandths cut, but it was taking 50 thousandths off the diameter. So anyway, a little bit different. I'm gonna have to remember that because this is the only lathe I've got that's got a direct read like that. But actually, I like that. So anyway, we're gonna dial in 100 thousandths this time. And actually make a true 50 thousandths cut. So we're at 140, that's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So we're going 240 on the dial. In this case, that's moving in 50 thousandths. So I'm taking a 50 thousandths cut, but it'll remove a total of 100 thousandths on the diameter. Fire up and let's run her down through there and take a little bit heavier cut. I'm really, go ahead, kind of looking to see what this machine will do, so shouldn't have any problems taking a 50 thousandths pass, or 50 thousandths cut. And you can see it's cutting it like butter. Sometimes these heavier cuts actually make a prettier finish than a light cut. I think we are set up to do these acme threads, so we're going to be cutting 8 threads per inch, and I didn't have an acme insert, so I actually just ground one over on the grinder out of some high-speed steel using a little gauge tool to get it set like it needs to be. I did that off camera. We've got the compound set at 14.5 degrees, which is half of my pitch angle, my 30-degree angle on this. 8 threads per inch. So to calculate how far you need to feed in on acme threads is the pitch plus 10 thousandths of an inch. So 8 threads per inch would be 1/8. 1/8, of course, is 0.125. So we need to go in 135 thousandths. So I'm going to set up an indicator. We'll put an indicator right here. I'm going to come in here and we can watch this and knowing we've gone 135 thou deep. And what we'll do, since we're working with a worn nut, we'll stop a little bit shy of that and start making test fits to make sure it's just right. Now, one cool thing that I really like about this Monarch, and again, I've never had this on a lathe before, is there's a little thumb screw over here on the side that engages some little dog clutches inside this hand wheel, and it's just for threading, because when you're threading, you know, you always, you feed in on your compound, so your depth when you're feeding, I'm going to go in like right here, you're feeding in on this axis here. But when you get to the bottom of your cut, you need to pull it out to get clearance. So you back off back here, but then you go back to 0 on this dial, and then you feed in up here. But what this lathe has got is it's got a stop in here, so it's a hard stop. So I can just come out and I can just go boom, and I'm on 0. It's just a thumb screw on the side. Really, really like this feature. Again, I've never had this on a lathe before, but this is something you see in the Monarchs, so I'm real happy to have that. And we've got everything set to 8 threads. I'm going to make a scratch pass just to make sure we're on 8 threads, and then we'll start cutting this. I'm going to let Tim do it. This will be his first time cutting threads, right? Mm-hmm. All right, so let me make the scratch pass first, and then to verify we're on 8 threads, then we'll start cutting. Wait for our little dial to come around to a number, engage. I'm gonna let it cut across a little bit. I'm just gonna back out of what making a very deep cut, but I'm gonna take my pitch gauge in here, line them up, and we are indeed on 8 threads per inch, so we're good to go. So let me go back to 0 here. Then we're going to feed in on this one. We'll probably start out, that first pass we can probably do, well, we'll probably make about a 5,000th step to cut. So I'm just going to dial it in on the indicator, about 5 thou. We'll lube this up. I'm gonna make the first pass here, and then we'll turn it over to Tim. We'll make sure everything's going good, and go. Y'all see that, guys? It hit me as I was going down through here on that first pass. I said, I wonder if that nut's left-hand threads. And sure enough, it's left-hand and we're cutting right hands. I've only made a 5,000 scratch pass, so I don't think it's going to be a big deal. We're just going to start over and cut in the other direction, but ding dong, left-hand threads. Should have thought of that. All right, let me get this thing turned around. All right, guys, I've reversed my lead screw direction, and we're basically going to be cutting out instead of in. It actually makes it a little bit easier because we can always start there on that inside. So let's just go with it. We'll make a pass or two, and then just double check everything. Come out. Go back to 0. And here we go. Take her. Let Tim drive. Okay, stop. Yeah. Come out. All right, that's plenty. Go back down to the trough we cut. Yep. Take your cross slide back to 0. To the stop. Just keep on going. You went a long way. Okay. Now dial that in where it says 10. Yep. And now we're ready to roll again. Go to 15, yep. Watch your dial and engage when it gets on a number. Well guys, let's show you where we're at here. We got our threads cut, and Tim did a really good job. In fact, he did such a good job he didn't quite know when to stop and went a little bit deep on the threads, but it's not a perfect fit, but he decided he's just going to go with it and leave it like it is. I'm going to take credit for messing that up because I had left him over here doing it. He didn't really know what he was looking at, and went a little bit too far, and I came over here and saw it and like, whoops. Anyway, I think it's going to be fine for just as a vise, but it's going to be kind of like a worn screw. But anyway, we can always go back and do another one later, Tim, if you decide you want to change. Now we need to work on the back side of this, and I just took a bandsaw, cut that off. I've got a collet in here. This is 7/8 inch collet, and we're going to just put the whole rod up in there and clamp down on that collet so we can work on this back side. And on this back side, you can see we're just going to leave a little collar there, turn this down. I believe that's 7/8 also. We'll double check that. We'll face this end off square, and then we're going to take it over to the milling machine and put a 3/4 inch flats on there where you can put a wrench on it and tighten it down. So guys, the last thing we need to do to this screw is to put the square piece on there where we can put a wrench on it. And to do that, I've got a square collet block here, and I've got a 7/8 inch collet. This is just a 5C collet block, and I can just drop this now down in my vise, clamp it in, mill the top, and we just roll this thing around and do all four sides, and it's just automatically set up nice and square. So I'm going to purposely do this where I'm just kind of flush with the front of my vise there, and it's about where we need to be. I'm going to drop my quill down to where it's just touching, back off, and I'm going to zero out my digital readout. I've done the math. We're at 7/8 inch diameter. And we're going to 3/4 inch across the flats, and to do that I need to remove about 62.5 thousandths off of each of the faces. So I'm at 0 right now. I'll tell you what I'm going to do though is I'm just going to dial in. I'm going to dial in 60. We're going to go around, measure everything, and then we'll go from there on the last little bit. So let's see. So we're at 60 thousandths deep, and I'm just going to come across that. And then I'll come out to the end. Take my back to 0 in this direction, so we'll be ready to go again on the next one. We'll turn this right there and do it again. So guys, in the essence of time, which we're running out of right now, I made this little nut over here just did some internal threads, cut this out real quick. I've got other videos showing internal threads, but this just threads right up on there like such, which is what we want. So this will drop down in here like such. All right, the jaw is moving. Got a little rock in there, Tim, but hey, that's self-aligning, right? It's a feature.
People pay extra for that.
People pay extra for that. I like it. So that's good. So now the last thing we need to do is go over to the milling machine. Let me get that just a little bit tighter. And we're going to have to drill a hole down through both of those parts and put a pin in there. And I think we'll have this resurrected. Let's see what size that is. I think we're ready to drill it. It's going to go all the way through. We just came through the back side of the screw. We're going through the bottom of the collar now. And there we go. Let's see if we can drive her in there. Look up there. Just like it was made for it. There it goes. Look at that. Ain't that pretty? So, what you think?
I'm happy with it.
You're happy with it? All right.
Except for where I went 50 thousandths too far cutting those threads.
Hey, you got to learn, right? Did you learn anything today?
Yeah, I definitely did.
So, do you think you could thread something if you had to now?
Yeah.
Okay.
Yeah.
Just need to maybe check your measurements a little bit sooner.
Check the measurements sooner and just keep practicing.
Yeah, it's all about practice. Well, all in all, guys, I think we're going to call this a win. Tim said he may want to come back and recut this thread at some point in time, just because it aggravates you, right?
Yeah, oh, so close.
But hey, this was a learning experience for him today. He wanted an opportunity to come down and get some hands-on experience. You've got a lathe that you at your shop, or it's not really usable right now, but you found one, right?
Dragged it out of a building it had been sitting in for 30 years unused. The verdict is still out on if I'm actually going to be able to do anything with it or not. But
okay. Well, he has a project, and maybe one day he'll have a lathe and he can start doing this, but he asked if he could come down and do a little hands-on work. I said, sure, he's not too terribly far away, so he came on down today and we did that. So hopefully it was a good learning experience for you, and if we need to, we'll make you another one. Do a try two, and maybe it'll be a little bit better. I think my problem was I left him to himself a little bit too long, but hey, that's how you learn, right? You learn by making mistakes, and at least the mistake today was not fatal to the part, not to you, but it's usable, but it's not exactly right. But we're going to go back. We'll fix it later on. Okay, guys, that's going to be a wrap.
thank you for letting me come down.
Absolutely. Thanks for watching, guys, as always, and leave us some comments. Subscribe to the channel if you haven't already, and we'll catch you next time around. Thanks.
See y'all.